In this video, we will learn how to write iterative tree traversals. We have already seen recursive tree traversal. We have seen recursive functions. Now we will write iterative functions for pre-order, in-order and post-order. Recursive functions we already saw. So if you want to convert a recursive function into iterative function, that is a function with a loop, then you may have to use your own stack. It's not necessary always. In some procedure, that depends on the procedure. So in some procedure, you may need to have your own stack. Means you have to use your own stack in iteration. So that's what this is the exam. In this example, we are going to use a stack. Without stack, we cannot convert recursion to iteration. So first of all, I will explain you the procedure. Then after that, I will write a function also. So let us start with the pre-order. Let me show you how we can perform pre-order iteratively without recursion. Let us perform it upon this tree. As I said, I may require a stack. So beforehand, I will draw a stack and keep it ready. Maybe it is useful. And here I am going to write on the output. And one more thing is, pre-order steps are first print, then perform pre-order on left child and perform pre-order on right child. That is root, left, right. So root means print. So first print, then go to left side, then go to right side. So let us start and follow these steps. Okay. So let us start from root node. T is here. This is the root node. What is the first thing I have to do? Print data. So I will print that data. 8 is printed. Then move on to left. Okay. I am moving on to left. Okay. Then on this again, what I have to do? Print data. Okay. Print 3. Then do what? Go to left side. Okay, I'll go on to left side. Then print data. First step here is print data for this node. Then go to left side. Okay, I will go on left side. Now T became null. Now do what? Go to right side. Watch carefully. Go to right side. Whose right side? This node's right side. Do you have the address of that node? No, T is there. So what is T now? T is null. Null means it is nowhere on the tree. So T became null. How do you get the address of this node? The address of this node is with this node and this address of this node is with this one and that is with root. So I should again come from root. That's what. This is the problem. So I should go back to this node and again remember I should go back to this node also to go on the right side. So I need those addresses. Then how to know those addresses? I should have pushed them in the stack. Yes, that's what I missed. So let me start over once again. I'll remove this. Let us start. T, first step, print data, print 8. Then what to do? Go on left. Going on left, but again I have to come back on this node so that I can go on right. So I need the address of this node. So I have not written addresses here. So I will write down address of that node 8, whatever the address may be. I don't know, right? Then go to left child. Okay, now move T here. Now what to do with this node? Print data. Okay, print data 3. Then you have to go on left. But before going on left, push the address of that node containing data 3, address of that node into the stack. That's perfect. Then go to left child. What to do here? Print 4. Push the address of this one into the stack. After pushing, go to left child. Now T became null. T became null. See, T is null, but stack is not empty. Stack is not empty, right? Okay, continue. What I want? I want the address of this node. Pop out the address of 4. Go to this node. So pop out and give it to T. So T knows the address of this node now. It's standing here, right? So when it's standing here, go on the right side. So the step is pop out, go to that node and move to its right child. Then continue. Again null. See, T is null, but the stack is not empty. Pop out an address. That's what? Address of 3. Okay, go to this node. Then move to right side. Now continue. For this node, what we have to do? Print. Push the address into the stack. See, only one address is there in the stack. So here it will be inserted. Then go to left side. It is null. If it is null, what we are doing? pop out an address, take t upon that address, and then move t upon right side. So right now also it is null. It is null and the stack is not empty. Pop out this address 8, take t over there, okay, then move to the right side. So whenever it is null, we are doing this, right? Now continue. T is not null, yes. So what to do? Print 5, right? And push the address of that 5 into the stack, address of 5 into the stack. This is the free space now. Then move t to left child. Again t is not null. Do what? Print 7, go to left child. Before going to left child, insert the address of 7 into the stack and go to left child. T is null. Null means what we are doing? Pop out the address, go to that node and move to its right child. So whenever t is null, we are doing this. Again t is null. Pop out the address, go to that node and move to right child. T is not null. When not null, print 2, go to left side. For left child, again push the address of that node. When you are going on the left child, put the address and go to left child. T is null. Pop out an address, go to that node and move to right child. So t is again null. Now t is null and there is nothing in the stack. There is nothing in the stack. So we have finished the procedure and we got the result. This is pre-order. So this is how the procedure works. So when to stop this procedure? When t is null as well as the stack is empty. Now let us verify our result. Pre-order. I'll just trace with the finger and show you. Pre-order, as I said, we should point the finger in this direction. Left hand side of 8, yes, 8. The next is 3, yes, 4. Then get inside. 9, then get inside. 5, then 7, then 2. Yes, it is perfect. Now I have to write on the program code. So already I kept few things there. A function pre-order taking pointer t upon root, and a stack is also available. Assume that stack is already initialized. What are the steps? We were repeating the steps. How long? T is not null and stack is not empty. Okay. So repeating the step means I will write on while loop. While t not equal to null, or it's not and, or not is empty st, stack is not empty. So while t is not null and the stack is not empty. If t is null, false. Stack is also empty, false. Both are false, it will stop. So I should use or. Then the steps. The steps are very simple. If t is not null, let us see the step again from here to get the idea. If t is not null, print data, push address, go to left child, right? If it is not null. So here, if t is not null, then three things: print data, push the address in the stack and move to left child. Print data, push t into the stack and move to left child if it is not null. If it is null, else what we should do? Else what we should do? See, when it was null, what we were doing here? What we did at that time? When it was null, we pop out an address and go to right child. So pop out an address from the stack, pop out an address from the stack and go to right child. That's all. End of loop, end of function. That's all. This is the iterative function for pre-order traversal, which is utilizing a stack. And one more important thing is the stack should be of which type? Integer type, character type. Which type? It is storing the addresses. So it should be of a type address of this node. So while writing the program, I will show you that.